Yes, okay. Now I'm on. Hi. And welcome to today's Plumbers of Data Science episode, everyone. Today we're going to look into Tesla. Tesla insurance, something that came out, I think today. Was it today or was it yesterday? So something totally new. And whoa, I'm on the wrong thing here. And I think it's worth discussing because this thing is powered by data science. And I mean, at first when you think about okay, Tesla is how can they do insurance? How does that make sense? How can they manage the claims and so on? And it's very very simple. And we're going to look into this. Um, yeah, before we start, and just wait for the people to come in. I want to show you something. I want to quickly discuss something that is important for me. Previously, during this week and on Monday, I said what we're going to do on this channel. What I want to do is I also want to go and do online courses to basically bring the podcast into a online course form. Of course it's going to be free. And a lot of people said, "Oh, Andreas, there are people like Frank Kane here who are doing super duper courses, and this will be hard, and this will be, they are very popular, and it's a huge competition." What people don't realize is I don't want to compete with them. I don't want to go into a Spark 2 with Scala hands-on course, 7.5 hours, and that costs something. My courses are going to be for free. And my courses are not going to be courses like these here, where we just where you look into single tools and make these. What I'm looking at, and I can show you what I already have prepared. I already have prepared five courses. The idea behind that is I'm creating a data engineering basic course. I've shown you this on Monday, and then I'm going to do basically courses that are where you're building pipelines. And because with this you're getting the whole picture. You're not only doing one thing and learn one thing. It's important to see the whole picture. So the idea here is we have already done some videos about how to get data from Twitter and with NiFi and put this into Kafka. This is what we already have. So what is going to be coming, or the first part is going to start building a pipeline with Twitter, REST API, and NiFi and Kafka. Then what we're going to do is analyze data with Spark and Zeppelin notebooks, basically this one here. This is also something that we basically did that. So this is going to be going into this course. And then we're going to build on this. So we're going to do a course where we are building a pipeline then based on the first part, Twitter, REST API, and NiFi Kafka. We're going to expand this, and we're going to do something with Spark and Zeppelin and Kafka. And another one, we're going to look into Elasticsearch. So we're going to build up courses based on pipelines and not just on a single tool, because I find it very important. I find it important to look into the whole thing, to look not into a single tool. And I want to look into pipelines, into giving you a way of learning the whole thing, like we did with the come on, with the streams I've done where we look into companies, how companies are working. I mean, with the use cases or the case studies. And we're going to build on top of that. And we're going to go there. And this is something that I have planned unique. And it's, I just want to, I want to open the Draw app. I don't, but how is that called? So I can draw on my screen. Disk. Oh man. Yeah. So this is a part. Another thing I found very cool. Rodney, one of the regular viewers, just posted on the last stream that he's scored his first job in the data science field as a junior data engineer. That's super awesome. I'm happy for him. That's perfect. And I hope at some point he was able to use something that I've been talking here on the stream. Screen brush. Oh man, just dumb sometimes. Because yeah. Okay, so yeah, I hope you all are happy and are having a good time. Again, always when you have questions or anything you want, just shoot. Pump out the questions. I'm going to make all the streams are more or less a big Q&A. So if you have questions, just shoot them, and I'm going to try to help you. And yeah, so then about Tesla. What I want to talk about Tesla. So Tesla, except that's not the thing I was opening it at first. So Tesla launched its own insurance, and because they had the problem. Oh man, these ads. They had the problem because Teslas are getting, or the insurance costs for Teslas are getting higher because they are high horsepower cars, and so insurers are putting them in a high category, in a sports car category, and it's getting expensive to actually insure these cars. And so Tesla has a new idea. They are offering their own insurance. Unfortunately, this text here changed between this morning and now, and I hate this when this happens, but yeah. Because this morning it said that it's also depending on the style your driving style. Now that it no longer says that, so what they plan is they're trying to do a 30% cheaper rate than everybody else. And you would say, how is this possible? How are they able to do this? And it's very, very simple if you think about it. When you're in the data science field, when you know the data science or how all this works. So Tesla is collecting a lot of data from their cars. They are, as I've shown you in a previous podcast in the case study on Tesla, they are, when you're coming home with your car, they are uploading a lot of car data to the cloud. And if it's in a service station, or if it's in a shop and getting repaired, they know exactly what is happening, and they know because the car is uploading the data and they're collecting a lot of data. As I understood now, so it says it's saying here 30% rate reduction, and Tesla knows its vehicles best. They're saying this. Tesla knows its vehicles best. And it's because they're collecting all the data. And they are... they know exactly what is happening. As I said earlier, this said it also the rate also depends on the driving style. If you're driving like crazy or not, it's a different rate. Now it no longer says that. I'm thinking this was maybe not 100% true, because in the Tesla insurance they say where was it? Insurance safety. Nah, where was it? Data. Driver data. Here. They're saying here. Come on. They're saying here in this thing, Tesla insurance does not use or record vehicle data such as GPS or vehicle camera footage. So I'm not 100% sure what this means in legal terms. That does not use or record vehicle data such as GPS or camera footage. So does that I'm not sure, does that mean no vehicle data or just not GPS and camera footage? Because this changes a lot. And yeah, so they basically, it doesn't record vehicle data. It's for me, it's not it's not super clear, because as I said, I haven't when I created the stream yesterday, I did not look into the terms. And the idea basically is Tesla knows their cars best, as they say, because they record everything and they know everything. And why does that work? Because if you have an insurance, Tesla is not an insurance company. Doesn't, of course. So what they're doing is they're working together with insurance companies. And how does that work? An insurance company, what they're going to do is they are going to calculate the risk of a damage, the risk of a payout that the insurance need to pay you for a claim. And so it's, if you have the repair data and if you know where cars are getting repaired, in which shops, and basically where is your home station, where is the car load recharging, then you know basically where are the people driving around, what is happening, how many of the cars in which part of the country are getting repaired, so you can make it, and also what serial numbers of cars are getting repaired, how old are they, and so on and so on. They know, because you buy the car from them, they know who bought the car, and so on and so on. So they have all this data that they're collecting either regularly from the car, maybe not vehicle data in such like GPS or camera footage or your actually driving skill, but telemetry from the car. How is the car basically? What's the status of the car? Sensor data from the car that are more in line, that are not showing how you drive the car, but how is the car working properly, and so on. So they then know the car works properly, and then it's in the shop. So you might have an accident. And again, I'm not sure what this means. If this says they are collecting no data, or if this says they're just not collecting GPS and camera footage. Because earlier the other pages said, I think Elon Musk said that or something. If you drive like crazy, your insurance will be higher. Alok, I see your comment. So again, if somebody has a comment, has a question, fire them out. I'm going to help and try to answer them for you. Yeah, so it's possible with all the data and with data science to figure out what is happening and figure out a risk of a car that is getting sold. How high is the risk that it's in an accident, that there is an insurance claim? And because of all this data, you can make very, very good predictions and calculate the possibility or make a prediction how many claims you have, and an insurer like a partner company, they need this as good calculated as possible, and then they're going to take care of the claims. So Tesla is not paying out, or Tesla is insuring themselves again for the insurance. And so if you have a Tesla insurance and you have a claim to Tesla, Tesla is going to tell the insurance partner to make a payout, and they are paying them also a rate. I hope this makes sense. So this is basically how this insurance stuff works. And it's, why is this possible? Because they have the data. And do you think this is something that comes from that is an idea from last week, or they thought about this month and they just tried it? I'm 100% sure this was their plan all along, and they had this for many months or for years in the back as a thought, and where as a vision where they are going. Because now they offer you everything. Basically, they offer you the car, the superchargers, the shops where you can repair or do maintenance on the cars. They're offering you the battery storage for your house. They're offering you the wall boxes. They're offering you the solar roof, and so on. So they're building up an infrastructure, and they're using data to basically find out who uses it, how are the people using their products, because the margin, how much you are you're making on a product, hardware is always lower margin than on digital products, on digital business. And so this makes absolute sense. Tesla said they don't have any actuaries. What does actuaries mean? Don't know what this means. Actuaries. I'm in the wrong. Come on. Either you already replied. No. Actuaries. I'm fighting with my keyboard because I'm switching between the actuary is nothing. Basically, the risk managers for insurance. They calculate probabilities and risks. Yeah. They are calculating the risk and the probabilities of a claim, because they have the data. And then what they can do is they can go to a insurance company and they say, okay, we are giving you we are paying you a rate per insurance, and the risk of you making a payment to our customer for the insurance is 5%. let's say 5%. And because they know how high the percentage is, or how high the risk is, and so they can go to an insurance company, and the insurance company is going to take the money, because if you can give a accurate prediction, and they have data, and so they can show the insurance company actually how they are coming to this prediction. It's very easy to sell this to someone, because it's a more or less a risk-free thing, except everybody starts crashing their cars, which I don't think is going to happen very fast. Yeah, I find this interesting, because this is a real use case of a digital business, a digital product, or a product enabled by data. The vehicle, more or less, is only a data producer, is only the tool to actually then sell the service, sell the insurance. And it absolutely makes sense. You're paying less. Tesla is having not that high of a risk, because to lose money, they know how this is going to turn out, and the insurer that is going to be the partner, or is the partner of Tesla, he's not going to have a high risk as well. And if they know basically what's going to happen, you can think further. If you have the driver data, and in Germany they are already starting to do this, that if you're driving slow, you're paying a lower rate. Some companies are starting to do this. Why not Tesla? Can happen, as the same thing can happen with Tesla. And of course, the more data they collect, the better is going to be the prediction. And this, you need data scientists, you need a platform, and you need the car who is going to send the data through the Wi-Fi at home to Tesla. Status data, how high is the battery, and so on, and vibration data, everything except the stuff that is related to the actual, let's say, driving experience. How is the driver driving? That doesn't really matter, because you know how the car is behaving, and if the car is behaving just right, everything's good, then if everything is good, and the next day it's in the shop, you know it has crashed, and it's very simple, and it's any more questions? Data engineering related. What we're going to do start on Monday is we're going to go and continue with the platform thought, the pipeline thought. So we're going to continue building stuff with Spark and with Zeppelin, and then we're going to this stuff is going to flow into the online course. Yeah. I know it's Friday. Not a lot of people are in here on Friday. I see a few people here. If you have a question, or if you want to say something to the whole Tesla thing here, I would love to get some feedback. And what else? Was there something else? I'm not 100% sure. So if there are no questions, then this was quite boring, because it might be on Fridays, but I just want to either way I wanted to come on and show you this stuff. And yeah. Okay. Then have a great weekend. I'm going to work on the courses and stuff on the weekend, and then we're going to see each other on Monday. Thanks, Ali. Yeah, I'm doing my best here. And yeah, one thing I want to show you. Haha. Exactly. I wanted to show you one thing on Medium. Now I almost forgot it again, but this is really important because come on. On Medium, let me just go there. On Medium, what I told you some time ago, the Plumbers of Data Science publication, and there is a really, really great new article from Manish, and this one I recommend to basically everybody if it's data scientist or data engineer. It's about SQL query optimization. Now you would say, SQL? Oh man, SQL is so yesterday's news. That's not 100% true, and a lot of people are working with SQL. SQL is still very important, and it absolutely makes sense to look into SQL and to understand it. And this article from Manish here basically tells you a story of how they went on, and they had a slow query and they didn't know what happened, and he's describing what they did to actually hunt for clues, as you wrote here, and how they figured out what is happening, where the problem is, and actually also how they made a solution for this. It's a longer article, but it absolutely makes sense to look into this. And I love SQL. Yeah, SQL. It's always going to be there. This is what people never understand. People don't understand that also in the world of NoSQL and big data and data science, SQL is still there and is going to be there and is as important as always. A lot of people know SQL and it's easy and it's easy and makes sense. You know what I mean. And for instance, if you're working with Spark, like we've seen in one of my videos about data frames and Spark SQL, you're working with this stuff, and it's very, very easy, and it's there and it's used, and a lot of technologies are building on top of SQL, and so it absolutely makes sense to look into SQL and look further into SQL and not only understand it, have an idea what could you do if something doesn't work. And yeah, I've even seen big data from a data lake after cleaned and aggregated being loaded into some large distribution relational databases like Azure, SQL Data Warehouse, Amazon Redshift. It's not going to go anywhere. No, exactly. And this is what people don't understand this. A lot of existing, this is also true, a lot of existing tools and technologies are built upon SQL. And so the UIs are built on top of SQL, and the production systems are built on SQL. And so it makes sense once you narrowed the information down, once you process the data, and once you have done the analytics, as you said, the cleaned and aggregated data, this can go into a data warehouse because there is your other data where you're going to connect it to, and that you're already using. And so it absolutely makes sense. And it's there. It's going to be there, and it's great. I mean, if you're going from unstructured data to more structured data, it makes sense at some point to put it somewhere where you can do SQL, because SQL is very, very structured, and that makes sense. And then there are a lot of there are some companies, not a lot. I mean, some companies who are trying to, or who are going the route to actually change their data warehouse. You can check out the stream I did, data lake versus data warehouse, who are trying to change their change from a SQL data warehouse to a NoSQL data warehouse. And what are they doing? They're not throwing away the stuff they already have. They're going to build the other stuff in parallel, and then they are trying it out, and maybe sometime in the future change bits to there. But yeah, it's still important, and it still makes sense. And for me, it's one in the this is why in the cookbook, I if you haven't seen my data engineering cookbook, let me just bring it up quickly. I have created a free data engineering cookbook that has over 100 pages right now, and one of the important things that I have is, so you can download it, GitHub. It's also in the description of the video, and I have one section that is the basics, basically data engineering basics, and one of the basics is SQL, and is going to be SQL. And yeah, please look into this. Check out the article. If you want to post more, or if you have something that is interesting, and you think this is going to fit into the Plumbers of Data Science publication, you can go to the publication and contribute. And then on the contribute is a article, how to write for Plumbers of Data Science. And this article basically basically describes what the steps that you should do to publish to this publication. If you want to, a really drill down version is you write a story, you send me an email, plumbersofdatascience@gmail.com, and then you attach the link to the draft or the story you have already published, and maybe some social media like LinkedIn, and then I'm going to publish your article, and I'm going to share it on social media and give you some views and help you build your profile in data engineering. Like with Rodney, who maybe I have nothing to do with this, but I find it absolutely awesome that he got a job as a data engineer. So this made my day today. And use this. I haven't even looked at the statistics lately. Let's just quickly look at the stats. Okay, here we had a spike. So on average, we have 112 visitors. Today we had, no, that was yesterday, 142. And minutes read and views. How is views different than visitors? 30-day average. Okay, visitor in the past 30 days we had around 4,500. So there are people looking into this. A lot of minutes read also. So check it out. If you have an article and you think it fits to the Plumbers of Data Science, to data engineering, platforms, processing, storage, visualization stuff, send it over. I'm going to help you publish this one. And please add a social media info so I can tag you on Twitter or on LinkedIn. Yeah. Okay, that is it so far. Yeah. If you have any more questions, write it in the chat, or add a comment to this video, and we're going to address it in the next stream on Monday. Yeah. Thanks for being here, everybody. Bye bye. Have a great weekend, and yeah, see ya.